Hi there, welcome back to the next video. In the last video, we made the hero a movable game object. In this video, we will apply gravity to this hero. We create a loop that keeps applying a y velocity to the avatar. We implemented a new method to determine if the object will hit any platforms. When the object is near a platform, we make it slow down and stand on the platform. Let's get started. We continue the project in the code editor. We should have the project folder opened. The Chrome Canary browser is ready also for testing later. In the movable game object, we had an initial velocity value to test the movement logic. We don't need them now. The world will have a y velocity applied to these objects. We don't need movable object to have a predefined movement at the moment. We reset the default velocity to 0. In the world class, we have created a function isObjectOnGround in the last video. Now we clone the isObjectOnGround to create a new method named willObjectOnGround. It is very similar to the original method. The difference is that it adds the velocity in the checking direction, so it can detect that the object will be on the ground in the next moment. By checking the diff of the two methods, we can have a clearer concept on the difference between the isObjectOnGround and willObjectOnGround method, which the willObjectOnGround takes the velocity into the checking, so it can determine if the object will hit the platform in the next frame. And it checks before the avatar's Y position hits platform's Y position. In the world class, we add a new method named ApplyGravity. It should loops through all movable game objects and apply a world gravity to them. Currently, there is only one movable game object, which is the hero. To make things easier, we mark a to-do comment here and directly use the hero as our target object. At the beginning of the function, we define two variables, gravity and terminal velocity. The terminal velocity is the maximum value of falling. The function that increases the object velocity by the gravity and restrict the falling velocity to have a maximum value equals to the terminal velocity. Then we check if the game object is going to hit any platforms. If the object is near a platform, we set the velocity to +1. This is to avoid the object's velocity is too fast, that it passes through the platform in the next frame. When the object hits a platform and its y velocity is still positive, we set the velocity to 0 to make it stand on the platform. We need to check if the velocity is positive because of the jumping we are going to implement later. When the avatar jumps, at the beginning, the avatar is near the platform, but with a negative y velocity, so it moves towards the upper of the screen. We don't want this jumping's y velocity to be reset by this logic. One last step before we finish the gravity logic. We need to invoke the ApplyGravity method. This is something we continually call, so we invoke the logic inside the tick method in the world class, which runs at 60 frames per second rate. Let's test the game in Chrome Canary browser. The hero falls from the top of the screen. Then it stops and stands at the platform. Now we have set the gravity to 1. Later, we may need to fine-tune the value to make the game play smoother. For example, if we make the gravity to 0.1, the initial falling speed is slower. We have made the avatar fall with a y velocity. In the next video, we will make it run by applying x velocity.